And another way to do this is by using some shortcuts. We saw this earlier. Some people were looking at the previous problem and going, isn't there another way to look at it? Is there another way to see the shortcut? And some of the students had developed. Well, I'm going to take this problem here. I'm going to switch that out for multiplication and switch that out for that. And I'm going to approach the problem that way and get 9/4. And moving on from here, how do I make that 2 and 1/4? Is I take that 9 and divide it by 4. 4 goes into 9 twice. And that gives us an 8. And 1 left over. 1, and we're looking for 4s. So 2 full times, 4 went into 9. We're looking for 4s. It goes right there. We have 1 left over. It goes right there. But my question to them is, why does this work? Why is this important? And why does it happen to work other than memorizing? Where does it come from? And so that's what we're going to look at now is where does that come from? Because a lot of students say, well, that's just my teacher showed me. Well, that's great, but why does it work? Why is it special like that? And one of the reasons goes back to the previous problem of getting 1 as your denominator. So if I look at it as a big fraction, 3 and 1/4 divided by 1/3. And the way I get 1 as the denominator is by multiplying this by its reciprocal, its flip. Remember, we flipped it over. And we realize we get 3 on the top and 3 on the bottom, and that gives us 1. And anything divided by 1 is itself, and whatever I do to the bottom, I got to do to the top. I do that same exact thing, and we multiply straight across, and that's how we get the 9/4. And again, how many times does 4 go into 9? 4 goes into 9 2 times. 4 times 2 is 8, with 1 left over, and we're looking for 4s. So it's another way to think of it, and another way and reason why that works the way it works.